Hello everyone. Now I want to discuss about the stability of a two-wheeler when the vehicle is taking a right turn. See here, we can see this diagram, line diagram I am considering. This is the front wheel. Assume that this is a two-wheeler. This is the front wheel. This is the engine and this is the rear wheel. So from this vehicle is moving in this direction, moving forward, and it is taking a right turn like this. So for this I want to discuss how to stabilize this two-wheeler. For example, when two-wheeler is moving like this, generally we are observing that if a two-wheeler is moving like this, whenever it is taking a left turn or right turn, the vehicle is somewhat bent like this. The total vehicle, whenever I am taking a right turn or left turn, whatever it is, the vehicle is going to bend like this. So when the vehicle is bent, then I can call that the angle of inclination of the vehicle with the vertical. If I assume theta, that theta I can call it as the angle of heel. That diagram I have drawn here, you see, assume that this is the two-wheeler. Whenever I am taking the right turn, the vehicle is bent like this. So when the vehicle is bent like this, the inclination of the vehicle with vertical, that is theta, that theta we call it as the angle of heel. So now from this discussion we are going to find out the value of angle of heel theta. Up to what angle I can bend. If I bend more than that angle, the vehicle is going to skid. It means to avoid skidding of the vehicle, up to what angle of theta I can bend the vehicle, that I am going to discuss here. That is about stability of a two-wheeler. Here, when the two-wheeler is moving like this and it is taking a right turn, then we are having a gyroscopic couple and again we are having centrifugal couple. Both are there. First, I will discuss how the gyroscopic couple will act and how the centrifugal couple will act. To discuss about the gyroscopic couple, we have to draw the angular momentum vector diagram. Assume that this is the two-wheeler, it is moving like this, forward motion. Forward motion means wheels are rotating in this direction. Wheels are rotating in this direction and it is taking a right turn. So, to draw the angular momentum vector diagram, what I will do is, you see, wheels are moving in this fashion. It means clockwise direction like this. I am folding my four fingers in this direction. Now the thumb gives the first angular momentum vector like this in this direction. So this I have drawn here. This is the OX. This is the first angular momentum vector. From here, this is the right turn. This is the left turn and this is the right turn. Now this is X dash. XX dash is the active gyroscopic couple and X dash to X, this is a reactive gyroscopic couple. Both the active and reactive gyroscopic couple vector directions are perpendicular to the board. It means like this. It means like this. Whenever these two directions are like this, the A direction of A active gyroscopic couple direction is towards the blackboard. And direction of reactive gyroscopic couple, that is away from the blackboard. It means like this, away from the blackboard. Now again I am going to use my right hand screw rule, whether like this. Thumb direction I have to place like this in the direction of reactive gyroscopic couple. Now the vehicle is going to turn in this direction. If it is the two-wheeler, if this two-wheeler is going to turn in this direction. This is the direction of reactive gyroscopic couple. So yes, when the vehicle is moving forward and it is taking a right turn, the gyroscopic couple direction is like this. This is the gyroscopic couple direction. And next, let me discuss the centrifugal couple, how it is. When the vehicle is taking in this direction, this is center, and away from the center like this, at the point of center of gravity, this is point of CZ. At the point of center of gravity, there is a centrifugal force Fc away from the center. Because of this Fc, there is a centrifugal couple which will act in this direction, like this. It means when the two-wheeler is moving forward and it is taking right turn, gyroscopic couple will be in this direction and centrifugal couple also will be in this direction. So both if I add, then I can call this as a Waver turning couple. This Waver turning couple, if I assume C0, this Waver turning couple C0 is equal to C1 gyroscopic couple plus C2 centrifugal couple. The derivation or formula for the gyroscopic couple C1 is equal to, this is V square by capital R into small r of wheel into 2I of wheel. I means moment of inertia plus or minus Z gear ratio into I of engine cos theta. And plus value, this is a positive sign, we are going to consider when the rotating parts of the engine and the wheels rotation are in the same direction. And a negative sign we are going to consider when they are in the opposite direction. And the next centrifugal couple, if I observe C2 is equal to centrifugal force into distance. How to get, this is Fc into h cos theta. How to get means, you see here, this is the two-wheeler. From here to here, this is a h. This is making theta with vertical. And this diagram separately I have drawn here. This inclined line, you see here, this is inclined line h. This inclined line is making a theta with vertical. It means here theta with vertical. Now if I take the components, this is a h cos theta and this is a h sin theta. Vertical component h cos theta and horizontal component it is h sin theta. So from this Fc, this is the centrifugal force. Whenever there is a centrifugal force, there is a possibility of centrifugal couple in this direction separated by this distance. This distance is h cos theta. So from this I can get centrifugal couple C2 is equal to Fc into h cos theta. So from this I'll get my overturning couple C0 is equal to C1 plus C2. Next, when gyroscopic couple and centrifugal couple both are acting in this direction, to balance this we have another couple, balancing couple, which is acting like this, that will be formed because of the weight of the vehicle. So you see here at the point of center of gravity, weight W is equal to mg, it is always acting in the downward direction. Because of this we will get balancing couple in this direction. That balancing couple magnitude will be equal to this force mg multiplied by this distance here h sin theta. So this is the balancing couple, that is equal to mg h sin theta. Now Waver turning couple, that is equal to gyroscopic couple plus centrifugal couple. That Waver turning couple is acting in this direction and a balancing couple is acting in this direction. Both should be equal to balance the vehicle. So whenever we are equating those two, it means Waver turning couple C0 must be balanced by the balancing couple mg h sin theta. From this relation we can determine what is the value of theta. If I get some value, theta is equal to, for example, 30 degree or 35 degree, whatever it is, it means that up to that much of angle, the two-wheeler can be bent without skidding. If that value is crossed the theta, then it means that the vehicle is going to skid. It means to avoid skidding, we are going to design the angle of heel theta value by using this equation. Waver turning couple C0 must be equal to balancing couple mg h sin theta. Thank you very much.